Sentence encoders play a vital role in natural language processing, enabling various downstream applications such as classification, clustering, and retrieval. Despite the prominence of decoder models, encoder models have maintained competitive performance in non-generative tasks, particularly in classification tasks. Sentence encoding, or sentence embedding, is essential for determining semantic synonymy, similarity, or relatedness among linguistic expressions, with a prototypical use case in semantic-driven information retrieval. The typical approach to comparing sentences using a regular encoder has the drawback of requiring a large number of comparisons, which becomes intractable for large volumes of data. Standalone sentence embeddings can be calculated using a Siamese encoder, an approach introduced by SBERT, which has become known as sentence encoding. This method brings closer together in vector space the embeddings of semantically similar sentences. Most NLP research focuses on English, leaving a lack of competitive and open sentence encoders specifically developed for other languages, including Portuguese. To address this, the authors present Serafim, a family of sentence encoder models, available in different sizes, that establish a new state-of-the-art for the respective core benchmarks of semantic text similarity and semantic textual similarity. The research focuses on open sentence embeddings for Portuguese, aiming to improve information retrieval in the Portuguese language. It discusses related work, including sentence encoders not specifically for Portuguese but multilingual and English models. The selection of models is based on their performance in the SBERT site and the MTEB benchmark. The STJIRIS family of encoders for Portuguese is introduced, which includes models trained using masked language modeling and TSDAE methods. These models are chosen for their high performance on various datasets. The methodology follows the SBERT architecture, focusing on developing new training methods for sentence encoders. The research paper presents the development of open sentence embeddings for Portuguese, focusing on both supervised and unsupervised training methods. Supervised methods involve two types of training. One using pairs of sentences annotated with similarity scores, employing loss functions such as cosine similarity, cos-ent, and angle, and another using pairs or triples of semantically close and negative sentences, utilizing the multiple negatives ranking, MNR, and gist embed losses. The authors chose gist embed due to its superior performance in trial experiments. Unsupervised methods were also explored, including the transformer-based sequential denoising autoencoder, TSDAE, and contrastive tension loss within batch negatives, CT. These methods do not require labeled data and are used as supplements to supervised methods. The final Serafim models were developed through sequential transfer learning, involving 4 stages with different types of data. The process began with pre-training base encoder models using CT loss on high-quality Portuguese corpora. Next, the models were trained for 10 epochs using gist embed on NLI datasets converted to triples. The validation splits of STS datasets were combined and used to select the best model checkpoint. In the third stage, the models were trained for 20 epochs using cos-ent and angle loss functions separately on combined STS datasets. The best performing model was chosen based on validation set performance. Finally, the models were trained for 1 epoch on a large information retrieval dataset using gist embed, resulting in the Serafim models for information retrieval. The paper also discusses the raw text data used for unsupervised training, including several Portuguese corpora from the Opus collection. The choice to use only the Portuguese part of these parallel corpora was made to focus on the target language. The paper highlights the development of Serafim, a family of sentence encoders for Portuguese that leverages pre-trained language models. The authors utilize monolingual and multilingual datasets, including EU Bookshop, Europarl, TED 2020, Tatoba, and labeled datasets like ASIN, ASSIN2, STSB Multi-MT, IRISSTS, PLU, and MMARCO. These datasets are crucial for achieving top performance in sentence encoding tasks. The authors also emphasize the importance of fine-tuning foundational models for sentence encoding, as this process significantly improves performance. Their experiments show that Serafim outperforms previous encoders for Portuguese by a small margin and multilingual or English-specific sentence encoders by a large margin. The paper underscores the significance of Portuguese datasets in achieving high performance in sentence encoding tasks. It also highlights the need for fine-tuning foundational models to produce top-performing sentence encoders. Overall, the authors demonstrate that their family of encoders, Serafim, is the state-of-the-art for Portuguese, outperforming previous encoders in various test datasets. The authors present the evaluation results of their Serafim sentence embedding models for Portuguese, showcasing superior performance on various datasets. Table 3 displays the results on the STS task, where the Serafim models outperform previous sentence encoders for Portuguese, as well as multilingual and English-specific alternatives, with Spearman correlation coefficients indicating strong semantic meaning capture. The authors note that separate training for Portuguese variants could lead to improved performance and that larger encoders tend to outperform smaller ones. On the IR task, the Serafim IR models, trained using the MMARCO data, achieve state-of-the-art results on the MS Marco test set, outperforming previous encoders for Portuguese and multilingual and English encoders by a large margin. The authors observe that the larger Serafim models perform better, except for the IRISSTS dataset, where the smaller 100M model outperforms the larger 900M encoder. This is attributed to the smaller model's ability to adapt to specific domains, such as the legal domain of the IRISSTS dataset. The authors highlight the significance of their approach in capturing semantic meaning in Portuguese sentences, setting a new state-of-the-art for Portuguese sentence encoding. They also discuss the development of open sentence embeddings for Portuguese, focusing on the creation of encoders with varying parameters to serve both European and American variants of the language. The authors present several models, including Saint Giras, Albertina, and Bertimbau, each with different parameter sizes, and mention future work aiming to enhance the encoder's performance through data augmentation techniques.